So here we are, Physics 111, Dr. Weaver's class. This is Project 3, and our project happens to be on thermography. The members of our group that will be participating will be Bethany, Michael, and Corey. So to start with, what in the world is thermography? What does it have to do with me? Believe it or not, it's based on something that is all around us. We just can't see it. Don't believe it? Well, here then, I'll show you.
Looking around.
Without it, these soldiers would be unable to see these potential terrorists as they pull a gun out and go to try and hide it in what would otherwise be invisible in the dark of the night.
Running off into the field. See this? Yep. I got a guy running, throwing a weapon. Smoke him. Go ahead and store that. Auto range store. There's another guy underneath. Move it right there. Good. Firing. Hit it.
That's right. None of this would have been possible without thermography. They would not have been able to identify them, let alone shoot.
Roger. He's wounded. Hit him. All right, hit the truck. Hit the truck and him. Go forward of it and hit him. Roger.
Oh, and wait, there's more.
This is CBS 2 News at 5.
Tonight on the health feed, a breakthrough in cancer detected.
We all know the key to survival is early detection. Mammograms have helped tremendously, but there is a new device the doctors say they can detect early warning signs.
And that new device is thermography.
Millions of women step up to the plate.
Is a tool, another tool we have in our armamentarium to screen women for breast cancer. A thermogram is a pictorial measurement of the heat generated from the body.
It looks like something out of a science fiction movie, but Dr. Darren Clare says the infrared imaging is a tool that can warn women up to a decade before the cancer even forms.
It takes 10 years from the moment of the cancer cell starting to be the size of a pea. That 10 years starts probably in the 30s. So we can catch it earlier.
So yes, possibilities are seemingly endless, whether it's in the military, in medicine, engineering, veterinarians, firefighters and other search and rescue, in security, or hunting, and yes, even in the ghost hunters use it. But wait, we still haven't even told you what is thermography. But know this, whether you like it or not, it is all around you. So let's find out, what exactly is thermography? What's it based off of? Well, for starters, it's based off something called infrared light. But here's Bethany to tell you a little bit more about thermography.
Thermography. So, what is thermography? Well, it's a technique that uses an infrared imaging and measurement camera to see and measure invisible infrared energy being emitted from an object. In simpler terms, thermography is the process of detecting and measuring an object's thermal energy. To understand thermography better, let's take a look at the electromagnetic spectrum. The electromagnetic spectrum is a range of all possible frequencies of the electromagnetic radiation. We know that infrared radiation is a form of electromagnetic radiation, which is longer in wavelength than visible light. Other types of electromagnetic radiation that you may be familiar with include X-rays, ultraviolet rays, radio waves, and gamma rays. Let's move on to thermal emission. Any object or particle that has a temperature above absolute zero emits thermal radiation. The temperature of the object causes the atom and molecules within the object to move around. When the molecules bump into each other, they change direction. Well, the change in the direction is equivalent to acceleration. When charged particles accelerate, they emit electromagnetic radiation. So each time a molecule changes direction, it emits radiation across the spectrum, just not equally. So, as a result, the amount of motion within an object is directly related to its temperature.
Molecules in motion. Molecules are moving all the time. Molecules in motion. Molecules that keep us energized.
Energies are there then? Well, let's give you an example. Mechanical energy is converted into thermal energy whenever you bounce a ball. Each time the ball hits the ground, some of the energy of the ball's motion is converted into heating up the ball, causing it to slow down at each bounce. Other forms of energy that we may be aware of are electrical energy, chemical energy, light from the sun that is converted to heat to warm the surface, and mechanical energy. Electrical energy is converted into thermal energy when you use objects such as heating pads, electrical stove elements, toasters, hair dryers, and light bulbs. Now that we have all this knowledge, we're on to next. Well, let's learn about emissivity. Emissivity is defined as the ratio of energy radiated by an object at a given temperature to the energy emitted by a perfect radiator. In simpler terms, the ratio of energy emitted by a material in comparison to how much infrared energy it emits. Now this is what we've been waiting for. Everything contains thermal energy and therefore has a specific temperature. This thermal energy is emitted from the surface of the material. This energy is called infrared radiation. The amount of infrared radiation emitted at a certain wavelength from the surface is a function of the object's temperature. Why is this important, you ask? Well, it implies that one can calculate the temperature of an object by measuring the infrared radiation emitted from it. How else do you think they find people hiding out in the middle of the desert? Like Corey mentioned in the beginning, there are a lot of uses for infrared. If our eyes could see infrared, we would be able to tell hot and cold without burning our tongues. Also, if we went hunting in the middle of the night, we'd be able to actually find something instead of just shooting air. As technology advances, we are finding more innovations for infrared being used every day. Did you know thermography and infrared radiation could see all this? So, with all this physics behind us, now we get to see how it actually comes together. So, you want to hear something more interesting? Well, have you ever taken a sniff of wasabi and you'll be hit with a familiar burning sensation? That's the result of chemicals in the pungent food hitting a protein called TRPA1, a molecule that warns us about irritating substances. The same protein does a similar job in other animals, but rattlesnakes and vipers have put their version of TRPA1 to a more impressive and murderous purpose. They use it to sense the body heat of their prey. How do infrared cameras work? Well, thermal imaging cameras have lenses just like visible light cameras. But in this case, the lens focuses waves from infrared energy onto an infrared sensory array. Thousands of sensors on the array convert the infrared energy into electrical signs, which are then converted into an image.
He uses the camera in rainbow mode because he mostly does household imaging, but you can also use the camera in black and white. So now he's displaying his lens made of germanium. He uses germanium because it's really good at sensing heat differences. Thermography is also very non-invasive because it doesn't send out any sort of rays. It only detects infrared.
Look at this photograph. Every time I do it makes me.
Here we see thermal imaging of someone that you may not realize you know. Yep, our very own Bethany. Hundreds of thermographers per year find overheated electrical components in people's homes. Who would know? It's used to find mechanical problems such as this overheated bearing in the AC pump. Once again, who would know? Here's an image of significant air infiltration. This scan was taken during a rainstorm. The home inspector was packing up, believing that he had found everything there was to find. Then, the thermographer found this: 2 large leaks from the roof onto the ceiling drywall. This moisture will likely cause black mold and damage to the drywall.
Goodbye, goodbye. Every memory of walking
have an elephant at the zoo. This elephant's foot had an infection that shows up as red and light pink. Infrared thermography is not a cure-all, rather, it offers a window of insight to help focus investigative efforts. So there you have it, thermography. We hope you enjoyed our presentation and learned something new. We'll see ya.
Someday we'd find out.
In the heat of the night, we are having a fiesta. We dance until siesta when the sun comes to life. In the heat of the night, we are having a fiesta. Let's dance until siesta.
Good afternoon, everyone. We're flying at 26,000 feet, moving up to 30,000 feet, and we got clear skies all the way to Las Vegas. And right now,
I just want you close.
Any lens, and this is a convex lens, because you know the difference between convex and concave. Maximum range for the voltage across it that will get electrons to move within the antenna. So, how big is the antenna in your car?
It's like 2.5 feet maybe, or... Well, let's talk to our radio people. What was the size of the wavelengths were?
So it's